Okay, today's lesson will be on unequal sloped common rafters, and in this case we'll be using a raised wall on the steep side to maintain overhang and soffit elevation. So first of all, we want to start out with some of the details here, and I show an 1112 on the steep side, and there's a 312 on the low slope side. Also, my building width is 2000, and my overhang is 300. So therefore I have a total width of 2000 plus 2 times 300, which is 2600. And what's important about that number, 2600, is it takes me from this very tip here to this very tip here. And as a result, I get the full length of the bottom of this perfect triangle, 2600. And that's really super important for all our calculations that will be coming up. So my next step is going to be finding a common rise to these two sides. So this is 11 and this is 12. However, this is 3 and this is 12. So that's not going to work for us. So what we'll do is we'll just multiply these two numbers by each other. So this will be 33 and this will be 33. So this was 3 times 11 is 33. So therefore 3 times 12 times 3 will be 36. So this side, if you want to look at it this way, will be 33 over 36. And on the right-hand side, or the low slope side, it will be 33, which was 11 times 3. And so this also has to be multiplied by 11, because it was 3 times 11, and that equals 132. So now that I have my rises similar, I can say that I have 36 units of run on the steep side, and I have 132 on the right side. So 36 plus 132 is equal to 168. Now where I'm going to use this number is drawing some proportions. 36 out of 168 units of run is on this steep side. I'll just draw a line here. And on the low slope side, I have 132 out of a total of 168 units of run. So to find out the actual length or distance from this point, this theoretical point, to this theoretical point, I would take the full distance all the way across the roof, which was 2600, and multiply it by 36 over 168. And that is equal to 557 millimeters. And I'll do the same thing on the other side. And I get 2043. Now my next step will be determining the slope gain factor for an 11 over 12 roof. .357, and the slope gain factor for a 3 over 12 roof equals 1.031. Now, just like a regular common rafter, I can take the run of the rafter, which in the case of the high slope side is 557, multiply it by the slope gain factor, and I'll get 756. What that tells me is that the distance between these two theoretical points here, 756 millimeters. Similarly, on the low slope side, take 2043 times the slope gain factor for this side, and I get 2106 millimeters. What is the height of my raised wall? I'm just going to compare the two overhangs. And my overhangs are 300. So I have 1112 is equal to x over 300. And on the low slope side, I have a 3 over 12 is equal to x over 300. And I'll just find the difference between those two. And 275 minus 75 is equal to 200. Therefore, this additional wall height that I'll be adding on will be 200 millimeters. Now, the last calculation I have to do has to do with the location of the bird's mouth. And what was critical about this very first step is that I didn't go to the top of the wall because I don't have perfect triangles in that location. So in order to get this perfect triangle all the way across the bottom and through the rafters, I have to include the overhang in all my initial calculations. What that means is, as I lay out my rafter, I need to know where the bird's mouth is. So this creates a triangle shaped something like this. So I need to know how far up, or alternatively, how far down the rafter my bird's mouth will be. And it's the same thing on the low slope side. So let's do the calculation on the low slope side. Here, if this is 300 from here to here, then the question is, how far up the rafter from the theoretical end will my bird's mouth plumb cut be? And it's a simple calculation. It's 300 times the slope gain factor for this side equals 309 millimeters. And on the steep side, the overhang is the same, 300 times 1.357 equals 407. So in this case, it's 407 millimeters from this point to this point, whereas the whole rafter is 756. And on the right-hand side, it's 309 millimeters from the outside corner to this plumb cut at the bird's mouth, whereas the entire rafter is 2,106. Now, let's imagine for a moment that this is our high slope rafter, and it's sitting in front of us on the bench. What we'll do is we'll pull our tape from this corner here all the way down 756 millimeters, the full length of the rafter. Then we'll take the 756 and we'll subtract 407 millimeters. It equals 349 millimeters. And what that will give us, it'll give us a point up here where our bird's mouth will be. So now with our tape hooked in the same location, we measure 349 millimeters. And that will give us this point here. So this line, this first line, we can hold our framing square on there at 1112. That will be our theoretical ridge line. Then we can draw a line here at 1112. That will be the plumb cut at the bird's mouth. And at the very bottom, we can draw another 1112 line, and that will be the outside of fascia. So at the bottom here, we can measure perpendicular to this line the thickness of the fascia, which will be 38. We can draw another line. So our fascia will sit in here like this. And what it means is that this is our cut line for our fascia. Over in this location, we're going to use a C cut of 38 millimeters. So we can measure perpendicular to this line, exactly 38 millimeters. And wherever that line intersects with the lower part of the rafter, we can extend that back like so. And these two lines will be cut lines down here. At the top, we have to do a shortening at the top. It's a little more complicated, unfortunately, at the top, because this theoretical line right here does not line up with the center of the ridge. So if I could draw this intersection here at the top, it would look something like this. Here's my ridge, and I have a relatively steep rafter coming off like this. And I have a relatively low slope rafter coming off like this. So where these two planes intersect, right here in this location, is the actual mathematical point. And it's from our initial calculations where we said that the left-hand side was 36 out of 168 parts, and the right-hand side was 132 out of 168 parts. So in the same way, since our ridge is 38 millimeters thick, and I can multiply 38 times 36 over 168, which leaves me with 14 millimeters. Therefore, the shortening at the top for the steep side will be 14. Now, if I go over to my layout here, in this location, I can measure over 14 millimeters, draw another line, and that will be my cut. On the other side of the rafter, I will have the total thickness of 38 minus 14 will be equal to 24 millimeters shortening. Now let's imagine that we have our low slope rafter here on the right, and in this instance we're going to assume that this corner up here will be up at this location, and so we hook our tape at the top corner and we're going to pull 2,106 millimeters all the way down and make a mark. This is our full rafter. Then I'll take 2,106 and subtract 309, and this is equal to 1,797. So leaving my tape hooked at the top, I'll measure down 1,797, and I'll make a mark here. This will be my theoretical cut at the ridge. This will be my plumb cut at the bird's mouth, and this will be the outside of my fascia. At the bottom, I can measure over the thickness of fascia, which in this case will be 38. Draw a line, and this is all at 3/12, and this will be a cut line. And then in this location here by the bird's mouth, I can measure over 38, which was the seat cut. Draw a line down, and then extend this where it touches the edge. I'll remove that material there. That will be my bird's mouth. And then over here at the top, I can do my shortening for my ridge, which as calculated earlier will be 24. Draw a line at 3/12, and this will be my cut line up here.